AP Cram, Calculus AB, Free Response, Exam Review, Question 51, Integral Expression for Position. All right, so a particle moves along a straight path for t is either greater than or equivalent to 0, or t is less than or equivalent to 5 units of time, whatever that unit of time may be. The velocity of the particle is given by v of t is equivalent to -2 plus t squared plus 3t raised to the 6/5 power minus t to the 3rd power. And the position of the particle is given by s of t. It is known that s of 0, so at time 0 units, is equivalent to 10 units of position. Write an expression involving an integral that gives the position s of t. Use the expression to find the position of the particle at t equals 5 units of time. This is actually pretty straightforward, so I'll give you a moment to think. Okay, so basically we need to find or create an expression that will involve an integral for position that will suffice for any time condition, whether the time is t equals 5 units of time or the time is 100, infinity, whatever. Okay, so we know our initial condition. At a time of 0 units, we're told that s of 0 equals 10. So that's our starting point. That's a known piece of information. Now, what about the rest of time? We don't have negative time, so it's completely okay to start at 0 time. For the rest of the other time conditions, we're going to have to integrate starting at 0 and going up to the time. So we're taking the integral from 0 to t, where t represents any time, of v of x dx. And just as a general rule, you should memorize that the integral of velocity is going to yield position, because we're getting rid of the x dimension or the variable on the horizontal dimension, and here our horizontal variable is time. So when you get rid of time in velocity, you're just left with the position or the distance measured in meters or some unit of travel, okay? So this is going to be our general expression for a position. So that's half of the battle. Now we need to go ahead and integrate at time t equals 5. But just so you can be clear, I don't recommend integrating v of x dx by hand because it's a long drawn-out process, and this is honestly not the time to show that you know how to factor out constants and separate variables and do integration. This is more of a problem of thinking and strategy than it is a one of mathematical aptitude, okay? So just to be clear, when you're going to input into your calculator 10 plus the integral from 0 to t of vx dx, or basically this is vx. It's really vt, my bad. But you know what I'm trying to say. So this is what you're going to input into your calculator. When they ask you for the lower limit, you input 0. When they ask you for the upper limit, you can put t if your calculator allows that, or x. I put x here because some people's calculator doesn't allow them to use such a variable, okay? And then your calculator should automatically input the dt for you, all right? But now we need to take the definite integral from 0 to 5. So what we're going to input is, again, this integrand, but this time our lower limit is going to be 0 and our upper limit is going to be 5. And just remember, don't write out v of x in your calculator. This is the function you're writing out, this function here, okay? All right, and when we input that into our calculator and press enter, you're going to get an answer of negative 9.207 units of distance. And what this means is, okay, let's say you started at the origin at 0. This means you would have traveled a little bit, like maybe 9 plus steps to the west, to the left, as opposed to traveling to the east or to the right. Okay, so this negative sign kind of just orients you a little bit, because some people have a difficult time imagining a negative position. Don't think of it as being the absence of something. Think of it as just, pushing you to the left or the west rather than to the right or the east. All right? Okay.